Okay, so let's talk about another type of measurement that we come across, and that measurement is density. And what's interesting about density is that it involves two of the types of measurements that we've talked about already. It involves talking about mass, and it involves talking about volume. And we'll get into the exact definition of density shortly. One of the things about density is that for the most part, density values are constants. And one of the applications of using density, as talked about on the slide here, is whether a substance will either float when placed in water or sink when placed in water. And it's based on whether it will float or sink is based on whether it is actually more dense than water or less dense than water. Water, essentially, has a constant density value of 1.00 grams per milliliter. So essentially, any substance that's less dense than water will float when it's placed in water, and any substance that's more dense than water will sink when it's placed in water. So if you take a look at cork and ice, which is actually another form of water, it's water in the solid form. Both of them have density values lower than water, and therefore you can see in the picture that they are floating in the water. Where on the other hand, aluminum and lead have higher density values than water. And as you can see in the picture here, they will sink when they are placed in water. Now, in terms of a definition, what do we talk about when we talk about density? Well, density is the comparison of the mass of an object to its volume. And essentially, in terms of the mathematics of it, when we talk about comparison, what do we talk about? We talk about division. So density is the mass of a substance divided by its volume. And if you take a look a little bit lower on the slide, you see the mathematical formula for how to calculate density. You take the mass of the substance and divide it by the volume of the substance. Now, of course, with any measurement, not only should you have a number, but you should have a unit associated with that measurement as well. Most often for solids and liquids, the usual unit for density that you come across is grams per milliliter. Now, why should that make sense? Well, because if you talk about mass, mass is commonly measured in what unit? Grams. If you talk about volume, volume is commonly measured in what unit? Milliliters. So if you have mass over volume, grams per milliliter is a very common unit that you would expect to come across. Also, on some instances for solids, the unit that you can come across is grams per centimeter cubed. And keep in mind that grams per milliliter and grams per centimeter cubed are essentially identical to each other because, as we talked about earlier, 1 milliliter is equal to 1 centimeter cubed. And essentially, those units can be used interchangeably. Now, for gases, the unit of density that you come across most often is grams per liter. And the reason why you come across that more often is because gases tend to occupy a larger volume. And as we saw a little bit earlier on, how do we commonly measure larger volumes? We commonly measure larger volumes in the unit of the liter. All right. So for solids and liquids, usually grams per milliliter or even grams per centimeter cubed. Gases, usually grams per liter. On the next slide here, you have densities of common substances. You don't have to memorize anything in this chart. A couple things just to notice. Notice that for solids and liquids, the density values are given in grams per milliliter. And notice for gases that the density values are given in grams per liter, reflective of what we talked about on the previous slide. And then also notice that these density values are given at specific temperatures, because as I mentioned, the one thing that can really change a little bit, one thing that can sort of change the density is a change in temperature. But outside of that, and even within that realm as well, we really consider density values to be constants. So we're going to go through an example of calculating the density of an object. So let's take a look at calculating the density of this object of zinc. So what they did here, if you take a look at the right-hand part of the slide, was that we have an electronic balance. And instead of putting the zinc object directly on the balance, they put a weighing tray on the balance first. Most substances cannot go directly onto an electronic balance because most substances are toxic and or corrosive. And if you put them directly onto a balance, you run the risk of really destroying the balance. So what they did here was they put the weighing tray onto the balance, and then what they did was they hit the 0 button on the balance. And what this does is that it sets the balance back to 0 with the weighing tray still on there. So that when they put the zinc object into the weighing tray, what came up on the screen of the balance is the actual mass of the zinc itself. And the mass of the zinc object here is 68.60 grams. Now, if you didn't have that writing on the bottom of the slide, how would you know that that is the mass of the zinc object? Well, the giveaway would be the grams. The fact that you have grams as the unit for that measurement there should be the indicator to you that that is the mass of the substance. We go back to the question in a sense, and it tells us that the volume is 9.5 centimeters cubed. So density is equal to mass over volume. We're going to take the 68.60 grams and divide it by 9.5 centimeters cubed. And when you divide 68.60 by 9.5, you get 7.2. And for the unit, you have grams over centimeters cubed, and that stays exactly as it is. 7.2 grams per centimeter cubed would be the density of this zinc object. Now, because density values are constants, we can use density to find mass or volume if the other is given. So let's talk a little bit about that. So we start with density is equal to mass over volume. And if we sort of write density itself as a fraction, and again, how do we write anything as a fraction? We can put it over 1. Well, now we have two fractions that are separated by an equal sign. And what's the correct mathematical operation when you have two fractions separated by an equal sign? The correct mathematical operation is to cross multiply. And what that leads us to is that it leads us to the mass being equal to the density times the volume, which is this equation right here. Now let me just work on the units a little bit to show you that this is the case. So if we have a density in grams per milliliter, and we have a volume in milliliters, when I multiply, what would happen to the milliliters? It would cancel. And what unit would that leave me with? It would leave me with grams. And as we would expect, for mass, a unit of grams would be acceptable. Now, from here, mass is equal to density times volume. We can take that, and if we divide both sides by the density, we can actually solve for the volume, where the volume is equal to the mass divided by the density. Now, let's show you the units associated with that. This is a little bit trickier. So, if you have you have mass in grams, and if you have density in grams per milliliter, you have a complex fraction. And how do we work with complex fractions? Well, the way we work with complex fractions is we multiply both the numerator and the denominator by the reciprocal of the denominator. So the denominator entirely cancels. On the top, the grams cancel. And what are we left with out of all that mess? We are left with milliliters, which of course would represent volume, all right? So again, if you have a complex fraction, how do you get rid of a complex fraction? You multiply the numerator and the denominator by the reciprocal of the denominator, and that gets rid of the complex fraction. Now, do you have to worry about all that? No, I just wanted to show you how the units work out, and that the volume is really equal to the mass divided by the density. Now, if you understand the algebra, all you have to do is remember the density equation, mass over volume, and you can solve for either mass or volume if given the other. But if you're not so comfortable with that, then what you'd want to do is memorize the other equations that are here.